All right, so we're moving along with all the operations of algebraic expressions, and now we're going to have a look at section 1.9, division of algebraic expressions. The quotient of any multinomial divided by a monomial is found by dividing each term of the multinomial, that would be the numerator, by the monomial, which is the denominator, and adding the results. So that's pretty wordy. Let's look at that in a formula sort of way to view it. Okay. So if I've got a multinomial, something maybe takes on this form, it's more than one term, so we have addition or subtraction between the monomials, and it is divided by a monomial, a single term. Maybe this looks familiar from what you did with fractions. If this was a fraction and these were being added together, or say I was working in the reverse, common denominator, I would just add the numerator, keep the common denominator. So when you are working with algebraic expressions and you have a multinomial divided by a monomial, then it is best to write each term separately over that monomial or denominator, and then do the division itself. So for each term separately. So let's have a look at an example. Here we go. What we're going to do now is see that we've got a multinomial, in this case it's a binomial, divided by a monomial. And I want to separate these two into two separate fractions, 6x squared over 3x and 9x over 3x. So this is how it looks. Now we just deal with this part and this part individually. And remember the laws of exponents for division. We want to divide the numerical coefficients. That's the easy part, 6 divided by 3. And then we want to perform the division of x squared over x by doing the proper thing with the exponents. Because the bases are the same, remember for division, you subtract the exponents. So we end up with 6 divided by 3, which is 2. And then x to the power of 2 minus 1, which becomes x to the 1. Over in the second term, 9 divided by 3, which is 3. And x divided by x, well, x over x, that's a 1. So that's like 3 times 1, or just 3. Okay, let me just write that one out for you again. Remember, on the second line, we had 6x squared over 3x. And the second fraction is 9x over 3x. Let's write out in a long form, okay? And then we're going to cancel. So 6. 6 could be factored. That would be 2 times 3 times, and then x squared is x times x. All over 3 times x. Over here, 9 is 3 times 3 times x, that's 9x, all over 3 times x. Now I grab my canceling pen and I start canceling. That cancels with that, that cancels with that. Over here, that cancels with that, and that cancels with that. And then we look at what do we have left. Well, up here, 2 times x. And about the denominator, everything got canceled, so that's over 1. We don't have to write it, but I'm just going to do that for now to keep track of everything that's going on. And that it leaves us with a 3. And what about the denominator? Everything canceled, so that's over 1. So really we would just say 2x plus 3. So that's the long way of how that one works out. Alright, so back to my slides. Here are some more examples. Let's have a look through. And I've got to notice the difference between the format of the two of them. This is a monomial divided by another monomial. So everything, the only operation going on up here is multiplication and multiplication in the denominator. So we can just go ahead and do the numerical division, 70 divided by 14. And then look at the bases, x to the 4 and y, x to the 4 divided by x, and then y over y. If you want to write that one out in a long way, that's okay. So you would be writing out 70 divided by 14, so that's 5. And then you would have x to the 4 minus 1, because that's division. And then you would have y to the 1 minus 1. So 5x to the 3, y to the 0. And remember that y to the 0 is just equal to 1. So this answer is 5x to the 3. Now this type, because we have a multinomial divided by a monomial, we want to make sure that we write each term in the numerator over this common denominator in the monomial that's in the denominator. So there we go. And now we just treat each one of these the same way we treated this one up here. And start doing division, canceling out whatever can cancel, subtracting exponents where bases are the same. So I'll let you write that down. Maybe pause the video and try to simplify this one yourself. And this is what you should end up with. Don't miss this last one. It's a negative. And xy over xy, well, that's just, anything over itself is equal to 1. It doesn't get dropped off. It's not a 0. So make sure that that becomes a 1 at the end there. Okay, so that has taken care of a monomial divided by a monomial, a multinomial divided by a monomial, and the last thing we want to look at is division of one polynomial by another. So this is a case where the denominator is not a monomial. Very different situation, and we don't write it out the same way we did with the other one where it was a common denominator. So these are rather tricky, and I would say this would be something that I want to introduce to you, let you know that it exists, but it's probably not something that you are tested on as much as some of the other. Okay, but I do want you introduced to it. So here goes. When you are dividing one polynomial by another, the dividend, that is the number or the polynomial that is being divided, and the divisor is the polynomial that's doing the dividing. Arrange each of those in descending powers of the variable. So highest power first, and then descending powers. And we are going to do division similar to what we would do with long division, the type that you did way back in grade school. If there are any missing terms, then fill them in with zeros. They're kind of like placeholders, so we do need them there as placeholders. I'll show you what I mean when we get to the example. Okay, so here I have my long division. It is a polynomial divided by another polynomial. And notice that I have arranged the terms in descending order of powers. So y squared is the highest power down to y to the 1 and y to the 0 essentially, right? And then y to the 1, and then y to the 0. When I said fill in any missing terms, if there was any power that was missing, like say this term was missing, it was just 6y squared plus 6, we'd be missing a y to the 1 term. We want to fill that in with a space holder like a plus y of 0y. Make a 0 in there. 0y to the 1. Okay, now the pattern for long division is divide, multiply, subtract, and bring down the next term, and then repeat that. Divide, multiply, subtract, and bring down. And that's the pattern that we're going to do. So let's see what it looks like when I write it out as a long division. Excuse the radical sign. It is not a division sign, but I couldn't find that in my symbols in Microsoft PowerPoint. So I intend to write this as a division, not a radical. All right, now we are going to take this polynomial. It is getting divided by this polynomial. Maybe perhaps because we're looking for roots of the polynomial. Okay. And the way to do that is focus on the first term in each polynomial, 6y squared and the 2y. Divide 6y squared by 2y. Maybe if you write that off to the side, 6y squared divided by 2y, you'll see where I get 3y. And that answer goes up here over the next term. That's what I mean by space holders. Line things up like this. So that's the divide. Then the multiply. If you remember with long division, we multiply this term by the divisor. So we want to do that. 3y times 2y and 3y times 1. And they go in these spaces. 3y times 2y and 3y times 1. And now we want to subtract 6y squared minus 6y squared. Well, that's 0, so that's not there. And 7y minus 3y is 4y. And bring down the next term. And now we repeat the process, starting with the first term divided by the other first term. 4y divided by 2y. And that goes here. It's a positive 2. 2 times 2y and 2 times 1. 2 times 2y and 2 times 1. And the next step is subtract. 4y minus 4y is 0, and 6 minus 2 is 4. And that's the remainder, because there's nothing else to bring down and continue. And that actually means that the remainder is 4 over whatever the divisor is, 4 over 2y plus 1. Oh, back that up a second, sorry. Okay, so like I said, this is not an easy process. It will take some practice for you. I recommend that you practice it, but please don't stress yourself too much about this. This is for advanced mathematics, and if you don't see that you will be needing it, then it's not my highest priority. But I do want you aware that this is how it's done, and it is not the same as just dividing by a monomial. Okay. The last slide for practice now then is 3 different types that we've looked at. Go ahead and give those a try. Pause the video and then unpause it. Check your answers. Alright, so there are the answers, and I hope that's going okay. And actually, please keep in mind the first 2 are really where I want you to focus. If you can do this, this is great. It is a little tricky. You got to remember all the steps. Okay, that's it for now.